welcome to Kids Coding Club. So this is the second session, and this week we're going to be doing the turtle race. We're going to be following along the tutorial that you can find online at the address that's on the screen now. So this is the tutorial that we're going to be following along today. I have a couple of other people here with me today. I've got Ben and Dave.
Hey everyone.
And they're going to be in the chat the whole time. So if you have any questions, then you can ask in the chat with the Q&A, and they'll help you. So if you remember last week, last session, we did a rock paper scissors game. This time we're going to do something a bit more advanced. So let's have a look first at what we're going to make. So this is going to be the final product. So it's going to be a turtle race game. So first of all, we're going to have the racetrack drawn out. And then our turtles are going to line up for their race. And then they're going to go and do the race. It looks like in this race, the blue turtle won. So we're going to be writing this game in Python. And to write Python in our browser easily, we can go to this web address here. So jump2.cc/python-new. That's going to open up this page for us to write our game in. So we'll just wait a minute for everyone to get onto that page. Ready?
Ben, could you just open that up on the screen again, and I'll put that into the chat to link.
Yep, so it's that address there. Cool. So hopefully everyone's on there. So to make this game, we're going to use a Python package, and this Python package is called Turtle. So we need to import this package to be able to use it. So what we're going to type in is we're going to type in from turtle import star. And what we're saying here is we're saying from the turtle package import star, which means import everything. We're importing everything from the turtle package because we're going to be using quite a lot of the functions that it contains. So rather than list them all, we can just write star. So now that we've imported the turtle package, we have access to a load of functions that allows us to draw on the screen using these turtles. So first of all, what we could try is we can use the command forward, and that's going to ask our turtle to move forward. But we need to tell the turtle how far to move forward. And we put that in the brackets. So we have forward, open bracket, and then a number. So we're going to ask the turtle to move forward 100 places. And then if we run that, we can see our line has moved over there. So our turtle is that little triangle there, and it's drawn a line 100 to the right. So we can see a couple of things from this. First of all, we can see that our turtle starts in the center of our screen. The other thing that we found out is that when the turtle moves forward, to start with, it is facing the right of our screen. So if we just wait a sec for everyone to get their turtle moving across the screen. Cool. All right. So we don't just want a line across the screen, really. We want to make a racetrack for our turtles to race across. And to make that, we need to write some markings, some numbers across the top of the screen. We could use that with the function write, which is also part of the turtle package. So at the very start of the racetrack, we're going to write 0. And then at the end of our racetrack, we could write 5. So if we run that, then we'll get a 0 at the start. So it's going to follow through the commands here. So our turtle is going to write 0. It's then going to move forward 100 places. And then it's going to write the number 5, which is what we see here. Okay, so we have our marking 0 and 5, but really we would like the numbers between as well. So we'd also like 1, 2, 3, 4 to be written there as well. So we're going to have to change our code a little bit here.
Ben, just quickly, one of our attendees can't see a line.
So if you can see my code at the moment, if you make sure your code matches exactly this in Trinket, when you hit the run button there, then it should work. Okay. So to add the extra markings, what we need to do is we're going to ask the turtle not to move quite so far when we start. So we're going to ask the turtle only to move forward 20, and then we can write the next marking 1. And we can keep repeating this. So the turtle can move forward another 20, and then the turtle can write 2, and so on, and so on. Okay, so what do we expect to happen when we run this now? So our turtle is going to start in the middle of the screen. It's going to write the number 0, then going to move forward 20, then write the number 1, then move forward another 20, write the number 2, and so on and so on. Let's see if it works. Looks perfect. The only problem with this code is it's quite repetitive, isn't it? So this is okay since we're only writing the numbers 0 to 5, but what if we wanted to make our racetrack even longer? Our code's going to get really repetitive and we're going to have to write this out loads of times. When we're programming, we don't really like to write very repetitive things because there's an easier way of doing it. So in Python, we can use something called a for loop. So I'll show you how to write one of these. So we can replace all of this with something much shorter. So we're going to write for, which tells Python that we're making a for loop. I'm going to write step in range 5. So what each of this means, so the for says that this is a for loop. Step, this is the name of the variable that you're able to use inside the for loop. So we'll see how we use that in a second. And then when we say in range 5, that's us saying to Python, we want us to loop round for 5 times. Okay? So what we can do inside the for loop, at the end of the for loop, if you press enter at the end, you'll see you're indented in a bit. So everything that's indented in under the where we've written for will be looped round. So this will be inside the for loop. So what we can do here is we can write, write step. So the step is the variable that was made in our for loop. So every time it loops round, the value of step is going to be increased from 0 upwards. So what we can do is we can write the value of step, and then we can move forward 20. So all that can replace that, which is much shorter. So now when we run that, we've now got something that's looking pretty good, but I'm not sure if it's quite right. So we'll just wait a sec for everyone to catch up with that. Okay. So you might have noticed that before we had our numbers going 0 to 5. However, this time we've only got 0 to 4. Now that's a bit strange because we've asked Python for range 5. The reason we've only got up to 4 is because when we're saying in range 5, we're asking Python for 5 numbers. That's what it means there. And we do have 5 numbers. 1, 2, 3, 4, 5. It's just our numbers are starting at 0 rather than 1. So to get back to 5 as well, we need to increase that to 6. So when we run that, that's looking good. That's what we had before. Cool. Okay, so we've got something that's starting to look a little bit like a racetrack here. However, the only problem is it's not really in the right place. As we discovered before, our turtle always starts in the center of the screen, but really we'd like our racetrack going across the top of the screen, and it's starting from the top left. So what we can do is we can tell our turtle to move before it starts making the racetrack. So what we're going to do is we're going to use the function goTo. So this is another function that's part of the turtle package. So we can write goTo minus 140, 140. So what this means is we're telling the turtle to go to a specific location. So in the center of the screen where the turtle starts, we'd call 0, 0. So it's 0 horizontally on the x-axis, and it's 0 vertically on the y-axis. So when we say go to minus 140, 140, we're saying go backwards to minus 140 on the x-axis, so horizontally, and then go up to 140 on the y-axis, so vertically. So we're asking it to do that before we make our racetrack because we need the turtle to be in this position before it makes it. So let's see what that looks like. Okay, so that's kind of looking something like we want, but we don't really want this big line here. It's kind of ruining the look of our racetrack a bit. So what we can do is we can tell the turtle not to draw. So by default, the turtle, everywhere it moves, it's drawing a line, but we don't really want it to do that at the moment. So there's another function that we can use to stop the turtle drawing, and that is called pen up. So if we write pen up before we do anything with the turtle, when we run that, there we go. So the turtle's not drawn where it's been, but it's just written the numbers. It's looking really good. So when our turtles are racing across the screen, we probably want some vertical lines here so that we can easily see how far they've got. So we need to be able to draw these vertical lines as the turtle is going along and writing these numbers. So we can do that within our for loop that we've already got here. So what we can do to be able to draw that, so we know that by default the turtle, when we ask it to go forward, it's moving right. But we can rotate the direction of this little drawing turtle to face a different direction. And the way we can do that is by using a command called right, and that's right as in the direction left and right this time. So we're asking the turtle to turn right 90 degrees. So that's a right angle. So if the turtle was previously looking towards the right of our screen, if it rotates clockwise, right, 90 degrees, the turtle is now going to be facing downwards. So we've now got our turtle facing downwards, just below the number. So what we can do is we're going to ask the turtle to move forward 10. That's just going to give us a nice little gap below the number to make our racetrack look a bit neater. We can then tell the turtle pen down. So this is the opposite of what we asked the turtle to do earlier. So when we say pen down, that means everywhere the turtle goes now, it's going to start writing and drawing a line. So now we've got the pen down, we can ask the turtle to move forward 150. So now the turtle's facing downwards and it's drawing, and it's going to move down 150. So now we've drawn our line for the racetrack. We can ask the turtle to lift the pen up again. So now we've drawn our line, but the turtle's not in the correct place to move on to the next number. So we're going to have to ask the turtle to reverse back up to the top of the page. So to do that, we can do the opposite of forward, which is backward. We're going to ask the turtle to move backwards 160 places. So now our turtle's reversed back up to the top, but it's still facing downwards. So we need to rotate the turtle back facing right again to be able to move on. And to do that, we can use left, which is the opposite of right. So the turtle can rotate 90 degrees to the left, so anti-clockwise. So it's ready back where it was to start with and ready to move forward to write the next number. So let's see how that looks. Cool. So you can see our racetrack is really starting to come together now. So we'll just wait a couple of minutes now, just so everyone's caught up with that. And make sure that on your screen, you've got a racetrack that looks just like mine. Cool. So hopefully everyone's up to speed with this. So what we can do now, if we look at our numbers here, they're not quite lined up with our lines. So it's making our racetrack look a bit unneat. Luckily, we can fix this. So where we're writing the number, we can say write step and then say comma, a line equals, and then center in quotes. So that will center our number on the line. It's important that when we write center, we write it with ER at the end. So that's the American spelling. That's something interesting about when we're programming. We often have to write our words with the American spelling. Okay, so let's see what that looks like. Cool. So our numbers are nice and lined up now. That's looking good. The only problem is our turtle's a bit slow at drawing our racetrack. If we make our racetrack any longer, it's going to take ages. But luckily, we can speed the turtle up a bit. So right at the beginning, we can use a function called speed, and we can put any number between 0 and 10 in there. So we can put speed 10, and that's going to make our turtle go really fast. Cool. Hopefully everyone's caught up with that. So now I've got a bit of a challenge for you. So at the moment, our turtle is drawing lines 0 to 5, but really I want 15 lines on my racetrack. So I want it to go from 0 to 14. How do you think that we would get more lines on our racetrack? Feel free to try it out, see if you can get there. Okay.
If anyone has got any suggestions on how to extend it, then feel free to put them in the chat as well.
How are your racetracks looking, Ben and Dave?
I'll be honest, Ben. I'm probably the least experienced here out of everyone, so I'm watching very, very carefully.
Yep, so far so good. It looks similar to yours.
So
Cool.
we've got some suggestions on chat as well. Someone has said change the range. Someone else has said step in range, open bracket 16, close bracket. I think everyone is pretty close to the mark on this. Replace the 6 in line 9 to 16. Yeah, replace the 6 to 15.
Oh, so it looks like we have a bit of a disagreement between 15 and 16. So yeah, it is a little bit tricky because our numbers start from 0, but we want 15 lines in total. So we're going to ask for 15 here. So that won't, our last line will have the marking 14, but there'll be 15 in total because we've also got a line that starts with 0. So great job everyone that suggested that. Okay. So this is looking pretty good so far, but I think even at speed 10, our turtle is a bit slow at drawing our racetrack. So I think we're going to set the turtle to maximum speed now. And to do that, we set the turtle to speed 0. It's a little bit confusing, but 0, when you're setting the speed of a turtle, means maximum. So, whoa, look at how quickly that is drawing now. Okay, so our racetrack is looking pretty finished now, but we haven't got any turtles to race yet. So I think we're going to have to make another turtle to race on our racetrack. So I think it'd be interesting maybe if Ben and Dave, you want to have a race with your turtle. So whose turtle should we make first?
Go on, Dave. We'll make you first.
Okay, right. So let's call this turtle Dave. And to make a new turtle, we're going to say Dave equals turtle. And you need turtle with a capital T there. And you need an open and close brackets at the end. So now we've made a new turtle called Dave. So Dave is the name of the variable, which is our turtle. We want to set the color of Dave's turtle. So to do that, we need to say dave.color. And like I said before, we need to remember to use the American spelling of these words. So we write color like that. And Dave, what color would you like your turtle to be? I think you might be muted.
Blue, please.
A blue turtle, cool.
Yeah.
And we want to make sure that Dave definitely looks like a turtle. So we're going to say the shape of Dave is a turtle, and that's in quotes as well. So there we go. We've made a new turtle called Dave. We made him blue, made the shape of him a turtle. So if we run that, we're going to have our racetrack drawn, as we saw before, and then we're going to have Dave appear in the middle of the screen there. Looking good. So we'll just wait for everyone to get their new turtle. So we can call him whatever you want in the variable name, as long as it doesn't have any spaces or funny characters in. So it's easier just to use a little word like that. Okay, hopefully everyone has their turtle ready. The only problem is he's not really starting at the right point. So when we're doing a race, we generally like to start at the beginning, don't we? He's cheating a little bit at the moment. He's halfway down the track already. So what we're going to do is we need to tell Dave to move to the start of the racetrack. At the moment, if we just ask him to move, if you remember what happened before, it's going to draw a line. So we don't want him to do that. So we're going to write Dave.pen up. So we're using the same commands as we did before, but because we want to tell it that we want to move this specific turtle that we've made here, we do Dave dot, and then we do the same commands that we did earlier. So we've written Dave.pen up. So that's going to make sure that Dave doesn't draw when he moves about.
Ben, we've just had a question to ask if we can slow down a little bit.
Yeah, okay. We'll just wait a second there for everyone to get their turtle ready.
Ben, could I be a different shape other than turtle?
Yeah, so I think there's a few different shapes that we can do. So I can try and find the... So if you... on the internet, you'll be able to find... there's this website here that if you're interested, you can look at afterwards. So this is in the Python documentation. We have the list of things for turtle. So what we can do, we can see all the different commands that you can use as a turtle here. And if we find shape, which is here, we can see the different shapes that you can use as a turtle. So there's arrow, turtle, circle, square, triangle, and classic. So if you want, maybe after you've finished this lesson, you could go and have a look at this and try out different shapes for your turtle. Cool. Okay, so hopefully everyone has their turtle ready. So what we were doing is we were asking our turtle to move to the starting line of the track. So what we did so far is we asked Dave to go pen up so that he doesn't draw as he moves across the screen. And then what we want to do is we want to use another command that we've used earlier. That's the go-to command. So we'll write Dave.goto. And a good place for this turtle to start, so that it's nicely lined up at the starting line, is -160, 100. So that will put the turtle at a good place to start. The other thing that we might want to do is after the turtle has moved to the starting line, we could do pen down. That's kind of optional, but that will just mean when your turtle races across the screen, it will leave a line where it's gone. So it's up to you whether you want that or not. Okay, should we try that out and see what happens? I'm going to hit run. So we've drawn the track like we've seen before, and there we go. Our turtle is now lined up at the starting point. So what we want our turtle to do really now is to race across the track. But it's going to be a little bit boring if he gets to the same point every time. It's not going to be much of a race if we know who's going to win every time. It wouldn't be very interesting, would it? So what we can do is we can add some randomness to how far the turtle goes. Now, if you remember from last week, we used a Python package called random. We're going to use the same one again this week. So under where we've imported our turtle package, we can import the random package, which is the same one that we used last week. Just to keep our files neat, we tend to import all our packages at the top of the screen, even though we're not using it until later on. So what we can do is we can type from random import. And then this time, instead of importing star like we did for turtle, we're just going to import randint. The reason for that is because we're only using the randint function this time. Unlike with turtle, we were using loads of the functions, so we just imported everything. So this time we're just going to import randint from the random package. Sorry. Cool. So just importing that package won't have made any changes to our game so far. We still need to tell the turtle to race across the screen. So we need to think of some rules for our game, and I think we should give the turtles 100 turns to move a little bit, and whoever gets the furthest in 100 turns wins. I think that sounds good. So we have a good way of looping round that we saw earlier, don't we? This for loop. It makes it really easy to loop the same bit of code over and over again. So we can use that again for our turns. So we can create a new for loop here. So to create the for loop in Python, we use the word for. And then we need to give a name for our variable that we can use. So this time I'm going to use the name turn. And I'm going to say in range, because I want 100 turns for the turtle to move forward, I'm going to say in range 100. So that means all the code that I put inside this for loop is going to be run 100 times over and over again. Okay? So how do we move our turtle forward? So we've seen how we moved this turtle earlier forward just by using the forward command. But if we remember, we want to make sure that we're moving the correct turtle forward. We want to move the Dave turtle forward. So what we can do Dave.forward. Now, how far do we want Dave to move forward? Well, if we put just a number in here, then he's going to move the same distance every turn. And then we're going to know how far he gets because it's going to be the same every time we play the game. So this is where we want to use our randint. So inside forward, instead of writing a number, we can write randint and then open and close brackets. And then inside those open and close brackets that we just made, we're going to say what the range of the random number we want is. So I want a random number between 1 and 5. So I'm going to write 1, 5 inside randint. So what we've got here is we've got a for loop that's going to run 100 times. Each of those 100 times, the turtle that we've called Dave is going to move forward a random number of steps between 1 and 5. So let's run that and see what it looks like. Cool. Our turtle has raced across the track. So we'll just pause there for a minute and let everyone catch up.
Okay, we've got one problem at the moment where somebody's turtle isn't moving at all. Obviously, Dave the turtle is moving, but hers currently isn't. She's also got the classic turtle. Why is there still also a classic turtle? Where is the old one?
I'm not sure if I quite understand the issue. So I get multiple turtles. So so the original turtle. So at the moment we have two turtles on the screen. We have the default turtle that we've used to draw the track, which is now parked up here. We've also got the turtle called Dave that's raced across the screen. So I'll share a link to my code. I'll put that in the chat. So I think if you click on that link, then you should be able to see the code that I've written so far. You should be able to run that, and hopefully that will work for you. Okay. So I think we're going to move on. So at the moment, we've got one turtle racing across the screen, Dave. But that's not really much of a race, is it? With just one turtle. So I think we might need another turtle. So is there anyone else maybe on the call who would like to put a turtle into the race? Ben, would you like a turtle in the race?
I would like a turtle.
Cool. Right, let's create another turtle then. We'll call this turtle Ben. So we're going to do this before this for loop, because if remember, this for loop is where we're actually running the race. So we're going to do it under where we've made our Dave turtle. So just like the Dave turtle, we can set a colour for this one. So Ben, what colour would you like your turtle?
Dave's gone with blue, so I'm going to go with pink, please.
Pink, okay. Nice pink turtle. And just like the other turtle, I think we'll set the shape to a turtle so that it looks the same. So now we've got another turtle ready to go. So if we run that, we see what we've got. Okay, so we've got Dave's turtle racing across the screen, but Ben's turtle is still just sitting there in the middle. So I think we've forgotten to do a little bit. So we need to move, first of all, we need to make sure that the Ben turtle is moved to the start line as well. So we're going to do something very similar to this. So we're going to set the pen up on Ben's turtle. We can then move Ben's turtle. We're going to set that to -160, 70. So that should put it just below on the screen. And then we can set the pen back down, the same as Dave's turtle, so that when it races across the screen, it also leaves a line. So we'll just let everyone add another turtle to their race. We'll just wait a sec for that. Cool.
Ben, if people want to add even more turtles, do they just need to do something similar to what you've just done here with Dave and Ben?
Yeah, so we could add another turtle underneath. So you copy something similar to that, put it underneath. So the important parts you'll need to change if you want another turtle. We need to make sure the turtle's got a different name for the variable. You might want to set a different colour for your turtle, and you'll also want to make sure the turtle starts at a different point. So maybe if you had a third turtle, a good place for it to start might be -160, 40 would be a good place for your third turtle to line up on the screen. Cool. So let's try that out and see what happens. Oh dear. So Dave's turtle has raced across the screen, but it looks like Ben's turtle has stalled at the lights, hasn't he? So what should we do? We need to, in our race here, we can see that we're asking Dave's turtle to move forward, but we haven't asked Ben's turtle to move forward yet. So we want to do the same for Ben's turtle. So we write Ben dot forward, and we want to make this race a fair race. So we'll do a rand int in the same range. So we can do rand int between 1 and 5. So again, that's going to, for every turn, we're going to move the turtle called Ben forward a random distance between 1 and 5. Okay? So let's run that and see what happens. Oh, who's it going to be? Hey! Beginner's luck. Ben's turtle has won. So we'll just wait a sec for everyone to get both their turtles racing across the screen. All right. Great job, everyone, if we've got to this point. So we've now got our turtles racing across the screen. What we can do now is we can make a bit more of a show of it, can't we? So maybe when our turtles get to the starting line, they could do a little spin round, a little twirl on the starting line. So where should we do this in our code? So let's say we want the Dave turtle to do a spin. So this is where we've made our Dave turtle. This is where we've asked him to go to the start line, and this is where he's racing. So if we want him to do a twirl at the start line, we're going to do it after here, because this is where he's sat at the start line. So what we want to do is we want to rotate the turtle around. We've seen earlier how we can rotate using the right and left commands. We want to make sure the turtle is facing the correct direction ready to start the race. So that means in total, the turtle has to spin all the way round. So that's going to be 360 degrees. So what we can do is we can use a for loop to do this. So we could say for spin in range, we could pick a number here. So I'm going to pick 10. And within this for loop, I'm going to ask the Dave turtle to rotate. Now I'm going to have to work out how many degrees I want him to rotate. So if we think we need the turtle to rotate 360 degrees in total, and I'm going to loop round this code 10 times. So because 10 times 36 equals 360, if we rotate the turtle around 36 degrees 10 times, in total, the turtle is going to spin all the way round. So let's see what that looks like when we run that. Hey! Did a little twirl at the start line. It looks like our Ben turtle didn't do a twirl though. And that's because we haven't asked it to yet, have we?
I did win again.
Yeah. Maybe that's because the Dave turtle was a little bit tired out from doing his spin at the start line. So I guess we need to make that fair, don't we? So after we've made our Ben turtle go to the start line, we can do something very similar. So we could say for spin in range 10, exactly the same as before, but this time we want to make the Ben turtle spin round. Maybe this one could spin round the other way. So we could say left 36 degrees. So that's still okay because 10 times 36 is 360 degrees. It's just going to spin round the other way. So this one's going to spin anti-clockwise. So let's run that and see what happens. And off they go. There we go. He's not so good after he's done a spin as well, is he, Ben? Looks like Dave Turtle won that race.
I feel cheated.
So we'll just wait a sec there for everyone to get their turtles spinning at the start line. Okay. So if we have a look at the example from when we started, it's looking almost the same as what we got, except the lines here are dashed. However, ours are solid.
Yeah, we've got quite a few questions pop
Oh,
up.
have we?
Yeah.
We just pause a second then.
Somebody would like to know, it's got two questions. Is there a limit in the race for the loop? What is the limit in race for loop?
So we know, so the turtle, so there's 100 turns that the turtles are going to move forward, and each of those 100 turns, each turtle is going to move forward a random amount of steps between 1 and 5. So the absolute maximum that the turtle could move is 500 steps if it moved forward 5 every single time for each of those 100s. However, it's quite unlikely that that will happen.
And are you able to share the code you've done so far?
Yeah, so I think I can share that again. So I can send that. So that's now in the chat. So someone's saying the numbers are going on top of each other. So I suspect what might have happened here is you might have missed something in the loop here. So this forward here at the end of our loop is asking the turtle to move forward 20 spaces before it makes the next number. So if you have a look at all the commands that are in this loop here, I suspect you might have one missing compared to mine. Okay, so if most people's got their got their turtles spinning and racing across the screen now? Hopefully so. So for the last few minutes, should we have a look, see if we can get these dashed lines like we do on the example one. So at the moment, our lines are just solid. So if we think back, because it was a while ago now that we made our track, wasn't it? So if we think back, it was in this for loop here that we made our track. So if we remember what we were doing, so we wrote the number at the top. We then turned right 90 degrees so that it faced down. We then moved forward 10 steps, and that was just to get this little gap here between the numbers and the lines. We then put the pen down so that we drew when the turtle moved forward in the next step. So we moved forward 150. We then lifted the pen up to stop the turtle drawing. We reversed back up 160. The reason that was 160 is because we needed to reverse the 150 and the 10 to get back straight to the top. We then had to rotate 90 degrees to the left so that we were facing the right of the screen again. And then we moved forward 20 to move to the next number to start drawing. So it's this line here is where we're drawing our straight line, our solid line, 150 long. So if we think about what a dashed line is, so a dashed line, how could we make that? So a dashed line would be drawing a little bit, and then not drawing a little bit and moving forward, drawing a little bit more, and then moving forward a little bit more. So this sounds a bit like a loop. So I think we could do this in a for loop to save ourselves writing this out so many times. So these are the lines, the important lines that we use to draw that solid line. So I think if we remove those lines and we add a new for loop inside the other for loop. So we're allowed to do that. We can put for loops inside other for loops. So this time I'm going to call the variable dash. So for dash in range, and I'm going to say in range 15. So that means all the code that's indented inside this for loop is going to be run 15 times. So we want, if we remember our line before was 150 long. So if we're running it 15 times, ideally we want to draw something that's 10 long inside this for loop. So first of all, we're going to put the pen down because we want to draw a little bit of the line. So we're pen down, and then we can move forward. Oh, I think I've got a spelling mistake there. Forward 5. So we put the pen down and moved forward 5. So that's going to draw a line 5 long. And then we can lift the pen up and move forward 5. So if we look, we've moved forward 5 here and we've moved forward 5 here. So in total, in this little block here, we've moved forward 10. We repeat that 15 times. So we've moved forward 10 15 times. And if we multiply that together, we can see that we've moved in total 150. And that's exactly the distance we moved before. So that should keep us in the right spot so that we still move backwards 160. It all still adds up to the same distance as before. So if we give that a run, see what that looks like. Great. So now our turtles have raced, they've done a little twirl, and they've raced across this dashed line racetrack, which is looking really good, I think. So, how is your racetrack looking, Dave?
It looks pretty good. It looks the same.
Great.
Obviously, on my screen, the blue turtle always wins.
You must be doing something wrong, Dave. On mine, the pink one wins every single time.
I may have slightly different numbers in the random int.
Cool. So we'll just wait a couple of minutes just for everyone to get their dash line on their racetrack.
Ben, we've had a good question from someone on the stream, and they've asked if they want to do the code themselves and modify it more. What are the obvious things that they could change?
So something you could add. So obviously we can add more turtles. We can add to the page. We could alter our racetrack. So say we wanted to have more lines on our racetrack, we could increase this number here. So the number that we put in here is going to be how many lines we have. So say I wanted 30 lines on my racetrack. I suspect though that if I put 30 in there to put more lines, my lines are going to go off the screen and I'm not going to see the end of my racetrack. So I would have to change another of the numbers in here. This one here, because if you remember, this number is the gap between the lines. So if we've doubled the number of lines, we could half the gap, and that will mean the lines take up the same amount of space. So there we go. We could have a racetrack with more lines on it. Although it looks like the numbers get a bit close at the end, so maybe you'd have to do a bit of experimentation to see what looks good on your racetrack.
Do we know if it's possible then to change the rotate speed?
I'm not sure. If you change the speed of your turtle, would that change the rotate speed? So maybe if you did Dave.speed, that might change how quickly he rotates. So I'll just set mine back to how it was before, because I think some people are saying that theirs wasn't working. I'm going to share the link again to everybody. So I've shared my code. If you click on that link in the chat, you should be able to see my code, and that's the finished product. Okay, I think we might be done there. So if anyone didn't manage to finish and they got stuck at any point, if you have a look at the instructions on this page on the Raspberry Pi website, it has all the instructions that we've been through here. So you can just find the bit that you got stuck on or wasn't quite working, and you can see what it says to do here. Okay. Cool. So thank you very much for coming, everyone. So this has been this Code Club session has been run in collaboration with Code Club. And we thank you very much for joining us. Thank you very much for Ben and Dave for helping me out today. And we'll see you all next week for a new project. Thanks, everyone.
Thanks, everyone.